Okay, welcome to Calculus 2. So, our first section that we're going to be working with today is going to be 6.1, finding the area between two curves. Okay, area between two curves. Okay, so the idea here is that we want to figure out the area between two curves. So, let's see here. If we have a function f of x and a function g of x, and we'll just draw the potato function in here. So, we might do something like that. And the idea here is that we want to figure out the area between these two. So the idea here is that we're going to get the area of this f of x function. And remember, the area under the curve, calculus 1, was the integral. We're going to get this area right here. Okay, this stuff in yellow, most more or less. Okay. And then what we're going to do is we're also going to integrate g of x. All right. And we're going to get that area. And we're going to subtract the two of them so that the only thing left is just going to be the yellow region, and that's going to tell us what the area between the two curves are. Okay, so we can subtract the two functions before we integrate or as we're integrating, and that's pretty much what we're going to do here. Okay, so let's do a little bit of an example. So what if I want to figure out the area between the two curves, and we have the curves of y equals f of x, or y equals x squared, and y equals 2x plus 3. Okay. The first step in doing a lot of these problems is simply to graph the two functions. Okay. Now, we're not going to be asking you to graph a lot of functions, but you should go back and remember how to graph polynomials, certainly how to graph lines, how to graph your rational functions, how to graph your logarithms and exponentials, and especially trig functions. Okay. So I've got my y equals f of x here. It's graphing the line. We're going to say 1, 2, 3. And we can say, okay, quack, quack, waddle, quack, quack, waddle. So we have kind of a line as we're going up here. Okay. So this is going to be the region that we actually want to go figure out. So we want to figure out what is the area between these two curves. Okay. And just like in Calculus 1, we have a thought about drawing little rectangles, right, which are our little dx's in here, and we're going to subtract the bottom function from the big function and get the area of all these tiny little rectangles here. That's going to be your integral. Okay. Notice in this problem, they didn't tell you from, to go from A to B or anything like that. Sometimes they do. Sometimes they don't. And this one, they didn't. So we have to figure out, like, well, where do these two curves intersect? All right, so that's one of the things that we're going to do here. How do we figure out when two curves intersect? Well, we set them equal to each other. Okay, so we could say this is 2x plus 3 equals x squared. We can go ahead and start solving this thing. So we'll subtract 2x from both sides here, subtract 3 from both sides here. So we have 0 equals x squared minus 2x minus 3. This is a pretty tame function to have to factor. So we have x minus 3 x plus 1. That'll go ahead and sort that out. So we can figure out that x minus 3 equals 0 or x plus 1 equals 0, giving us our x is equal to 3 or x is equal to negative 1. All right, so when we go ahead and sort out our integral, we're going to be going from x equals negative 1 to x equals 3. So we can say this, negative 1 to 3, right? Remember our integration symbol from calculus 1. The next thing we have to figure out is which is the top function. They won't always tell you, they won't always draw you a picture. So what you're going to do is you're going to take a point somewhere between your two bounds, if that's the only intersections, right? So later they're going to cross over each other. We'll see what happens then. But we could pick a x equals 0 in both of these cases and see what the y values are. So with y equals x squared, we have y is equal to 0 squared, which is equal to 0. Or we have y is equal to 2 times 0 plus 3. That's going to give us 3. Which one is bigger? Well, the 3 is bigger. So the line goes on top of the parabola, okay, in this case. Okay, so we can say the line goes on top of the parabola. It's going to be a 2x plus 3, right? Was it 2x plus 3? It was 2x plus 3. Good job. Minus x squared, okay? And then we're going to integrate this whole piece here. One of the things that I would like to do is I would look to put these in either ascending order or descending order, just so that my calculus turns out to be a little bit prettier. So we're going to say this is -1 to 3. And I just changed the versions around. I'm going to put my negative sign at the end. So we have 3 plus 2x minus x squared. And we're just going to integrate like this. All right. Now, we're just doing product. We're just doing power rule here. So remembering back to calculus 1 for the product or the power rule, we're going to add 1 to the exponent and divide by whatever's left. Okay, so it's going to be 3x to the 0 plus 1 is going to be 1 divided by that 1 plus 2. We have x to the 1. We're going to add 1 to 1. And we have x. 1 plus 1 is x squared divided by that 2 minus x to the 2 plus 1, 3 divided by that 3. Now, this is a definite integral. You do not need a plus c with a definite integral. So we're going to be going from -1 to 3, right? If it was an indefinite integral, you would need a plus c, okay? But since we have bounds, we don't need the plus c, right? Let's clean this up a little bit. So we have 3x plus x squared minus 1/3 x cubed. -1 to 3. All right. Now we have the hard part of the calculus problem, the arithmetic. So we have to plug in the little values here. So we're going to say we have, okay, when x equals 3, so we have 3 times 3 plus 3 squared minus 1/3 times 3 cubed. Okay, minus, and this was at x equals 3. I'm going to put my other little brackets in here. So we have 3 times -1 plus -1 squared minus 1/3 times -1 cubed. Okay, and this is x evaluated at -1. You may do this any way you have that's easiest for you to figure out how to do this. Okay, if you see somebody on a YouTube channel, or like, oh, I really like the way they did that, or you visit a tutor and they're like, oh, you did that perfectly. I don't know what my teacher's doing, but he doesn't do it as nice as you. Use the method you like, okay? Because the hardest part is keeping your numbers straight and making sure this thing all works. So that's the kind of the tough part of this thing. So I encourage you, find a method that works for you and use that method. So we have 3 times 3 is 9, plus 3 squared is 9, minus, well, 3 cubed is 27. 27 divided by 3 is 9. So we're going to say -9. Okay, and that's my first little bit here. Okay, then we're going to say we have 3 times -1, which is -3, -1 squared, so add 1, and then we have 1, 2, 3, 4 negative signs. We have plus 1/3 here, right? Negative times -1 cubed, that's going to be -1 times this -1 over here. So we have our whole little piece here. And this again, this is x equals -1. This was x is equal to 3. Now we just have to start simplifying some of this stuff. So 9 plus 9 minus 9, we're going to get 9. Okay. And then here we have -3 plus 1. That's going to give us -2 plus 1/3. All right. And there's a negative sign in front of this thing. So with negative times negative is positive. So we add plus 2 here, minus 1/3. So it looks like we have 11 minus 1/3. So let's go ahead and see what that is. We'll go ahead and get a common denominator. So we have 33 over 3 minus 1 over 3. So we end up with 32 over 3. And that is our answer for this problem. All right. And that's how you do a problem like this. This is the area between the two curves. This is exactly what you're going to be dealing with this. Okay. So this is what the end of. All right. Let's do the next one. So we are going to try to figure out the area between y is equal to sine squared x and y is equal to cosine squared x between or on 0 to pi over 4. Okay, 0 to pi over 4. Okay. And it tells us this in the problem. Okay, it tells us 0 to pi over 4. So we don't have to worry about trying to figure this out. We do have to kind of figure out, well, how do we figure out the top and the bottom here? What is the cosine of 0? Cosine of 0 is 1. 1 squared is going to be 1. So we're going to be up here somewhere. What is the sine of 0? Sine of 0 is 0. When we square it, we get 0, so we're going to be down here somewhere. Fortunately, I know that sine of pi over 4 is equal to the square root of 2 over 2. Cosine of pi over 4 is equal to the square root of 2 over 2. What a coincidence. So that's where they're going to be the same. So we're going to say this is going to be our pi over 4. Uh, Square root of 2 over 2 is about 0.7071, so that's going to be about where this is. So we're going to have a curve doing something like this, a curve doing something like this, and we're looking for like, what is the area of this little wedge piece in here? And that's what we're going to try to figure out. So let's set up our integral. So we're going to say this is going to be between 0 and pi over 4. So the top one is our cosine. So we have cosine squared x minus sine squared x, parentheses, dx. We have to integrate this. Before you jump into the integration, the integral of cosine squared is not cosine cubed over 3. You can't do it that way. You don't know how to integrate cosine squared yet. We will learn how to do that in this course. So we can't just look at this and say, oh, we can just integrate. No, 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 we can't. So we have to go ahead, go back and remember, like, oh, yeah, this reminds me of cosine squared minus sine squared. I kind of remember that being cosine of 2x. So this piece here, there's a trig identity to say 0 to pi 4. This was cosine of 2x dx. Now this one I can integrate, okay? So if you remember, like, okay, how do I integrate this? You might have to go back and say, let u equals 2x du equals 2dx. Well, I don't have a 2dx. So when I go to start doing my substitutions, I can integrate, I can substitute my u for my 2x. I can integrate this piece. But what I really need here is 0 to pi over 4 of cosine of 2x. But I need a 2 dx in here in order to substitute that. So I can't just go around multiplying things by 2. I have to multiply by 1. So if we're going to multiply by 2, I also have to multiply by a half in order to cancel this stuff out. Okay, so let's go ahead and make this a little bit more of a thought here. So we have 1/2 integral between 0 and pi over 4. We have cosine of 2x is now u. My 2 dx is du. Okay, I know your book does it a slightly different way, but that's okay. Okay, again, the way you do your substitutions, pick the way that works best for you. We're going to make sure that that works for us. But we're not quite done yet because that's not right anymore because these were the integration limits for x. I'm now in the u world. Those are not the same integration limits. So we have to fix that. So what did we say? We said let u equal 2x. Okay. Okay, so when x was equal to 0, u is equal to 2 times 0, which is equal to 0. When x is equal to pi over 4, u is equal to 2 times pi over 4, which is going to be pi over 2. Now we have good limits. So this is going to be 1/2 integral between 0 and pi over 2 cosine u du. Right? So if you remember the derivative of sine, okay, is equal to cosine. Therefore, the integral of cosine must be equal to sine. Okay, so we can go back and say that. So we have 1/2 integral of cosine is equal to sine of u, and we're going from 0 to pi over 2. Okay, so there's that 1/2 was out in front, so we don't have to worry about that anymore. Our u du, we integrated, so we used this all up. We integrated. So that's the whole point. So we have 1/2. Here's the sine of pi over 2 minus the sine of 0. Plug that in as the brackets. 1/2, going back to our unit circle, sine of pi over 2 was 1. Sine of 0 is 0. Okay, that 1/2 out in front. 1 minus 0 is just 1, so this is equal to 1/2, and that is our answer for the area between these two curves. Okay, so one of the reasons I wanted to show us this problem explicitly was that there is a lot of trigonometric identities in calculus 2. I know that we don't always reinforce that stuff into calculus 1. So as you're going through this, I'm like, oh, I forgot how to do trig. It's one of those things. Go back and look at how to do trig so that you won't be taken by surprise when we start getting into some of this stuff. Okay, it's important to go back and be able to do all of that. All right. So that was my example. That was my sneaky example here. All right, let's see here. We didn't want to do this one. We wanted to do, I think we wanted to do this. Well, yeah, we'll do this one. All right. Sometimes, normally we've said y is equal to f of x. There's going to be a lot of times and places in our problems where it's going to be kind of tough to work on functions that are explicitly represented as x's. Sometimes, especially 6.2, 6.3, 6.4, it's going to be easier for us to say x equals a function of y. So we might have x is equal to some kind of a function of y. It's not really a function because it fails the vertical line test, but it's still a relationship and it still works. But you have to get used to drawing things kind of sideways and figuring out that way. Okay. So we'll go ahead and figure out what's happening with that one. Okay, let's see here. Um, all right, let's work on this one. So why don't we do, okay, so why don't we do find the area between, okay, let's do with x is equal to 4 plus y squared and x equals 2y squared. Okay, we have to figure out that area. Again, first thing I'm going to do is go ahead and draw it. Now, 4 plus y squared is kind of like a vertical, like if I was going to do 4 plus x squared, it would just be parabola with a vertical shift. It's just a parabola with like a right shift. Okay, so we say 1, 2, 3, 4, and we're going to have a value that's going to look something like this. Okay, we'll have that. Now, what if I wanted to graph y equals or x equals 2y squared? Well, again, if I wanted to say y equals 2x squared, it's just a parabola that starts at 0, but it's stretched out a little bit. So we would do something like this. We would say, okay, it's going to do something like this. It's going to do something like this. Okay. So really what we want to do is we want to get this area here. Okay. Now, just like the original functions, we top minus bottom, when we have these side-to-side functions, we have this x equals f of y's. We're going to go from right to left. So we're going to say the right function minus the left function. Okay. In this case, the 4 plus y squared is the right function. So we could say, okay, this is going to be 4 plus y squared minus 2y squared. Okay. Now, there is one thing we have to do before we can start going and integrating this stuff. Okay. Where do they intersect? How do we do that? Again, we set them equal to each other. So we're going to say this is 4 plus y squared equals 2y squared. So we have 4 plus y squared equals 2y squared. Again, I really like to have my coefficients to be positive. So we're going to subtract a y squared on both sides here. I'm going to subtract a 4 from both sides on this one. So we have 0 equals 2y squared minus 1y squared. We have y squared minus 4. Oh, not like I didn't pluck this one out of a textbook. So y minus 2, y plus 2 is equal to 0, y is equal to 2, or y is equal to negative 2. Okay, so those are my points of intersection. We have a negative 2 down here. This is y equals negative 2, and y equals positive 2 up here. I don't really care where they actually are, though. Okay, the x values, those are nice. But really what we care about is we're integrating with respect to y because we're adding up these horizontal rectangles rather than vertical rectangles. Okay, so when I go to figure out my integral here, we're going to go from negative 2 to positive 2. And what are we trying to integrate? We are saying we are integrating y squared minus 4. Right? Actually, we're going to go ahead and do this. We're going to say we have 4 plus y squared minus, and here we have minus 2y squared. Okay, all times dy, because we're doing horizontal rectangles in this case rather than vertical ones. And we have to sort this out a little bit to make this a little bit more pleasant. So this is going to be a negative 2 to positive 2. We have the 4 didn't change anything. We have a y squared minus 2y squared, so minus y squared here. And we have our dy. Now we have to integrate with respect to y. So this isn't too bad. So this is going to be 4y, right? It's y to the 0, so we pretend we add 1 and then divide by it. So we have 4y minus 2 plus 1 is 3, so we have y cubed over 3, going from -2 to +2. Right? And that's what we have for this. So we go ahead and we have to plug in some stuff now. So we have 4 times 2 minus 2 cubed is going to be 8 over 3. Let's put that in parentheses. Minus, and now we have 4 times -2. Let's put a -8 in here. -2 cubed is going to be -8. So we have -8. We have minus. Let's go ahead and go a little bit slow with this one so we can keep our signs straight, SIGN signs. So we have minus, that's this minus, minus, and we have -2, that's -8 over 3 here. All right. So that's what we have. All right. We have 8 minus 8/3 here. That's my y is equal to 2 minus, and then here we have -8. This is y is equal to -2. Okay, minus a negative. So let's go with a plus 8 over 3. All right. And now what we're going to do is we're going to distribute this negative sign here. So we have 8 minus 8 over 3. This negative sign comes in here. So we have negative times negative is an 8. We have negative times positive, so minus another 8/3. So now we'll combine our terms. So we have 8 plus 8 is 16. And then we have minus 8 minus 8 is minus 16 over 3. All right. So as we're figuring this out, you're going to be allowed to use a calculator. All right. You're allowed to use the calculator. It's okay. You can't use a particularly fancy calculator, but you can use a calculator. Okay. So that's going to be 30 and 18. That's going to be 48 over 3 minus 16 over 3. Let's go ahead and add these two things up. So we have 8 minus 6 is 2. 4 minus 1 is 32. So my answer for this piece is going to be 32/3. Right? And that's what I would report for my answer. And that is the area between these two parabolas, figuring out what's going on here. All right. So that's how you do these kinds of problems. There will definitely be a part 2 with this thing. I'll say thank you very much for watching the video. I'll see you in the next one. Take care. Do your homework.